All right, welcome back. This is topic 1930009. This is core thermal limits. And this will be a question that we'll have to calculate from hot channel factor the maximum linear power density. There's three questions on this. They're very similar. Been used on 3 exams in the past, and yeah, I'll show you how to do all 3 real quick. All right, PWR core consists of 50,000 fuel rods. Each fuel rod has an active length of 12 feet. The core is producing 1,800 megawatts of thermal power. If the total heat flux hot channel factor, also called the total core peaking factor, is 2.0, what is the maximum linear power density? So max linear power density is what we're using. And if you recall from the lecture, or if not, I just want you to know that hot channel factor is going to be equal to max LPD, linear power density, divided by the average. And the average LPD is going to be kilowatts per foot, right? And it's going to be the total divided by the feet of rod. How many feet of rod? So we've got 50,000 times 12 feet of rod, right? So we're going to have 1,800 megawatts by 50,000 times 12 feet. All right, so we're going to do that like this. We're looking for average linear power density is what we're getting now. So we'll do a railroad tracks. 1,800 megawatts thermal, and 1 megawatt is equal to 1,000 kilowatts, and 50,000 rods, and that's at 12 feet per rod. Okay, so see if we got our units correct. Megawatts cancels. Now we've got kilowatts. Rods cancel per foot. Kilowatts per foot. So that's going to be our average linear power density. And that average linear power density is going to calculate out to 3. 3 kilowatts per foot. So now we use this, right? Therefore, from this equation, max LPD equals hot channel factor times average LPD. So max is going to be equal to 2 times 3 kilowatts per foot. So they were nice to you. They didn't give you 3 kilowatts per foot as a choice here, right? You have 4.5, 6, 9, and 12, right? So this answer is obviously B. So they're actually pretty good to you, right? So that equals 6 kilowatts per foot is the max. This looks very familiar. You got 50,000 fuel rods, active length of 12 feet, course producing 1,800 megawatts of thermal power. So let's just not do the calculation again. Average linear power density is going to be 3 kilowatts per foot. And hot channel factor on this problem is 1.5. So max LPD is going to be hot channel factor times average LPD. And that's going to be 1.5 times 3 kilowatts per foot. So max LPD is going to be equal to 4.5 kilowatts per foot. And that is indeed the correct answer. And there's a third one just like it. Again, 50,000 fuel rods, 12 feet long, core is 1,800 megawatts. So we know average LPD is equal to 3 kilowatts per foot. And we know that hot channel factor, which equals 3, is also going to equal max LPD over average LPD. So max LPD is going to be equal to 3, the hot channel factor, times 3 kilowatts per foot. so it could be 9. So it's fairly easy. The big concept here is the hot channel factor is max over average linear power density. Thank you.